A typical application of Monte Carlo analysis is predicting yields on production runs of a circuit to display families of data derived from Monte Carlo. For example, histograms. In this video, we will create a Chebyshev filter and modify the Monte Carlo histogram. So let's get started. In the first step, we are going to open the existing project, which I have already created for you, and you can download that using the link given in the description. So let's start the OrCAD capture using Cadence program menu. Select the license and click on OK button. In the next step, we are going to open the project. To do that, we'll go to File, Open, select Project, and here you have to locate where you have downloaded the file. In our case, my files are saved on desktop, so I'll go to Desktop, go to the folder and select the chebi.opj file and click on Open button. Once the project is open, we are going to open the schematic. So let's double click here. So this is the schematic that we are going to simulate for Monte Carlo analysis and plot histograms from it. In the next step, we are going to edit the PSpice model of capacitance and resistor. So as of now, this is Chebyshev filter, which is designed to have 10 MHz of center frequency and 1 kHz of bandwidth. And the components that we have used here are 1% resistor and 5% capacitors. Alright. We are going to edit the models of resistors and capacitors. So since we have used the implementation property, so we have to edit just one capacitor and resistor PSpice model, and it will be updated everywhere else. So we'll just select the resistor first, right click, go to edit PSpice model, and the model editor window will open. Here I'm going to make this deviation to 10% and then save the PSpice model editor. Then we are going to just pick one capacitor, right click, edit PSpice model, and make sure you have 5% deviation here. So this is fine. We don't need to change the deviation here, and close this window and then save the project. In the next step, we are going to edit the simulation profile. To do that, we'll click over Edit Simulation Profile tab. From here, make sure analysis type is AC sweep analysis, and make sure you have selected the logarithmic scale. Start frequency will be 100 and will be 1 MHz. Number of points per decade will be 50. Then we'll go to Monte Carlo tab. Here output variable is Vout. For now, we are just going for Monte Carlo analysis. Random number seed 137, save data all. So this is the parameters that you need to set in your case, and click over apply and OK. Next, we are going to run the simulation. To do that, we'll click over run PSpice simulations button. Here we go. So now it will ask how many Monte Carlo iterations you want to simulate for. We'll select all and click over OK. Here we go. So here we have our Vout at different frequency range. Alright. So this is our band pass filter. Now in the next step, we are going to plot histogram. To plot the histogram, we'll go to Trace, go to Performance Analysis. So from here, make sure analog section currently selected 100 out of 100. Variables changing between Monte Carlo run number and range is 1 to 100. We'll click over Wizard. We'll go to Next. And make sure here we have selected the band pass bandwidth filter for 3 dB, and here we have to enter the trace name. To do that, we'll click over Next. And from here, we have to select the trace, which is Vout in our case. So we'll select Vout and click over OK button. Then Next. Alright, so here we have the performance analysis ready. We'll again click over Next button. And here we have the histogram. So for this histogram, we have all the data here. So you can go through with that, and based on this data and results, you can make changes on your Chebyshev filter and rerun the analysis. For more tutorials, visit us at resources.emaeda.com, and don't forget to like and subscribe our YouTube channel.